Welcome. So my goal of this video was to make an AI, artificial intelligence algorithm to solve Minesweeper, and preferably do it quickly. So I used minesweeperonline.com to play Minesweeper, and I did it in Python. So first of all, a bit about Minesweeper. So the rules are really simple. Um, you have 99 bombs on the screen, and you need to find them all. And when you do, if you do it successfully, the game finishes. If you click on a bomb, so the game ends, and you need to start all over again. That's the basic idea. I need to flag all the bombs without exposing them. Uh, okay, so how did I approach it? First of all, something I realized you have two classes of square, two groups of squares. You have the closed ones and the open squares. For example, closed squares, you have two kinds. Either like this, the unknown squares, which are haven't been clicked yet, and you can have flagged squares. Here, those are flag squares, which I suspect they have bombs, and the rest are like closed unknown ones. I call them unknown squares. And then the other group of squares is the open squares, basically those that I clicked on, which are all the number squares and the blank one in the middle. And if I click on a bomb, so the bomb is also an open square. But that's the two groups I had. So that's the logical separation. Now, I didn't want to program the game itself, but I wanted to use the online version, and in order to solve the online version, I basically I used image grab to take a screenshot of the screen of the board, basically, analyzed it, and using pyautogui to click on the correct buttons. And so that's the introduction to my project. So the main challenge was actually figuring out what the board looks like from the screen. Obviously, if you see it, it's really simple, but converting it to code, like analyzing it in my program, wasn't so simple. So the first part of code I wrote was basically I called it refresh board, which is a piece of code to read the screen and analyze what we see. Why wasn't it so simple? Because first of all, figuring out the content of each square is based on the pixel colors. I used the pixel color to determine the square's content. I thought it would be simple since you can see each number has a distinct color, but actually it was a bit more complicated because if you look carefully, you can see that, for example, each one is composed of different shades of blue, each two different shades of green, three different shades of red, and so on. And you can see that the flag also has red in it, like the three, and some black, like a bomb. So I couldn't just sample a single pixel and figuring out the square from the content. It had to be a little bit more complicated. Also, if you play in a few different online versions, they might have different shades. By the way, I just noticed this bomb is different than this one. You can see this is different than this part, and here you have the black line, which you don't have here. So that's kind of funny. Okay, so let's go quickly over the code I wrote for the refresh bomb. First of all, my first function is read board. I define the board according to all the pixel locations, which I already calculated, and I'm calling refresh board. Refresh board is kind of straightforward. I go over a number of columns, number of rows I have. I calculate the pixel for each square. I move the mouse there, so I would visually see what square am I inspecting. I extract the surrounding pixels around the mouse, just so I have a few pixel colors, and I infer the square from the pixel colors. I print it. If it's a bomb, I might quit, and then I set the value on the board, and eventually I print the board. Now let's run it. Let's run it and see if it works. Oh, right. Okay, you can see the mouse moves through all the squares, reading each one. And now eventually, I should have, is this the same board? Let's see if it's the same board. Okay, yeah, those are indeed the blank lines, the black line at the top. We have the 3 ones on the right. Those are unknown. Question mark is unknown. Yeah, I have 3 flags, 3 squares which I flagged, and the 3 is in the middle, those 3. Yeah, so it worked now, eventually. Good. So that was the first part. Okay, the second part was to write the algorithm to solve it, to solve Minesweeper. So right now it's running in debug mode, so you can see the mouse movement. Um, so what I did is an iterative process of calculating Bob probabilities, marking the definite bounds, opening certain squares, etc., and doing this repeatedly. Once I'm not certain where the bomb is anymore, like I don't have complete certainty, so we take an educated guess according to the highest probability. You can see that once in a while I do scan again all the board to see what has changed, and then calculating the probabilities and so on. This is the beginner mode. Let's see, it's gonna finish soon. Yeah, okay, great. So it finished in 47 seconds. Obviously, it's not so good. This is because you can see all the mouse movements and I'm scanning the board. Wait, let's run it again, not in debug mode, so we don't see all the mouse movements. And now I'm also counting the number of clicks I'm doing to see where we can improve it further. So you can see everything is much faster. It's gonna finish hopefully soon. Oh, no. It had to guess. It guessed incorrectly a bomb. Let's run it again. Okay, board looks good. You can see that it takes time to reread the entire board, but yeah, now it's gonna finish. Okay, awesome. So it finished in 17 seconds, and you can see that right clicks were the minimum. Right clicks is to mark a bomb. So I marked the 10 bombs. That's the minimum right clicks required. However, I did have a lot of middle clicks. The middle click is supposed to expose a neighbor unknown squares for when all the marked bombs for a number were marked. For example, if I have 1 and I mark this one, when I double click this one, it should open all the neighbors. So it's more efficient to use it. So you can see this happens quite a lot. So this can probably still improve and reduce the number from 17 seconds. Run it now on expert mode. When I say a few conclusions. So first of all, this is an open source project. I'll put a link in the description. Feel free to fork it and contribute and work on it if you want. It's totally open source. While developing it, firstly, I tried to do it on Minesweeper.online, and they blocked me because they realized I'm doing some AI stuff. So now I'm using minesweeperonline.com. I was a little bit disappointed when I realized it's not so quick as I thought. I thought it would be incredibly quick, but probably the mouse movement. So analyzing the board, I'm not sure because eventually the code is many iterations, but like simple iterations with simple logic. So it's probably the mouse clicks which are a bit slower. I have to figure it out. There is room for many improvements. For example, the logic could definitely be improved. And the efficiency, like you can ignore once you realize a square is blank, you can ignore it forever now, or when the number has all the bombs, all the flags around it like already present, you can ignore it from now on. No need to analyze it or double click it. So there is a room for many improvements. It was a fun project. And feel free to contact me if you want, if you want to contribute, if you want to continue, if you want to consult on how to do stuff. I would be happy to talk to each one of you. Thank you.